in C. You can get what you are used to are things like you can say int x, and that gives you a variable x. You can say int a bracket 100. This gives you an array of size 100. What these things are about, so I'm starting here at the bottom, is that so here we're setting up our variables, our storage when. Pretty much as the program begins. That new command can appear anywhere. In fact, it can appear inside of a loop. And if it appears inside of a loop, each time, so it's usually new something. It's new, the syntax is new, followed by a type. Like new int. And so each time, for instance, new, so this is the type name. Each time new int runs, we're asking the operating system, give me a new storage location. Now that doesn't happen if you have a loop. Yeah, I can put inside of it here int x equals 30, but I don't get a new x each time. I just get the same old x and I put a 30 in it. Here, each time we do this, we get a new place to store something. And so we can get a lot of new space. In fact, you can say new int brackets 100. And so rather than getting a single integer, what's coming back is going to be an array. We're going to have an array able to hold 100 integers. So this new is powerful. There's some chance that the operating system is going to say, no, I'm not going to give it to you because I'm out of space, or somebody else is using it, is using a lot of space, so I can't. You don't expect that to happen, but it's a possibility. So how does the operating system say no? We'll talk about that in a second. So what new does is it gets you new space, and what it returns is so you get enough space to store an integer. You get enough space to store 100 integers, so you get space, and what's returned by new is the address of where that space begins. So you get space, and new returns the address of that space. So you get space, and when you use new, you get the space that you asked for, and the second thing is new returns the address of where that space begins. Okay. So we'll talk about delete in a second. Are there questions on new? So when I say new followed by a type name like int or float, or if what we were doing on Tuesday was we had a struct. So what's a struct? A struct, say I want to keep information about you and you and you. I want to keep your name, I want to keep your student number, I want to keep your grade on the midterm. So we could say here struct, I'll call it, so the name, so struct is the key, another key word, struct. Struct, stu, open brace, and now so what we're going to be saying here is what's going to make up the structure called stu, that is student. Well, we're going to have here int student number, SN. We're going to have the student's name. So care name brackets, I don't know, let's say 50. Room for 50 characters. And let's say midterm grade. Let's keep that as an integer, int midterm. So what I've got here then, inside of this structure, is I've got a place for a student name. Sorry, a place for a student name called name. I've got a place for the student number, which is of type int, and a place for a midterm grade. How do you use stu? Well, in C++, how do you use int? How do you use the type int? You say int x, and that gives you a place to store an integer, right? So you say stu, and you make up something, s. And so this is a type name that we've just declared. So, so what is s? S, I'm not using new yet. We haven't got around to using new yet. We will very soon. So I've got the, so s is of type stu. So s has in it, each s is of this type. So that means that s has in it a place for a student number, a place for a student name, and a place for a midterm grade. And so I can say here, for instance, s dot sn. So you connect up the, so s is the name of this of the variable. It comes in 3 parts. So this is kind of like an array that has multiple parts, but these parts can be different. So another term that you see, kind of an more old-fashioned term to structures, they're called records. That this is a student record. Now, I'm not, the actual student record that ISU maintains is probably a lot more complicated, right? But okay. So if I've got this declared, and then I can say s dot student number equals, I don't know, 991, 2, 3, 4, 5, 6, 7. So then this student has this for the student name. Let's now so has this for the student number. Let's do a string copy. We're going to copy into s dot name. I don't know, Alice Bob. Is that a name? Alice Baker. There we go. So I'm going to copy Alice Baker in for name, and then let's give Alice a midterm grade. I don't know. Remember, this is out of like 38. Let's give her a 35. So that's a pretty good grade. So notice this dot notation. S dot sn. That's the student number for this student s. S dot name. That's the name for this student s, and the name happens to be Alice Baker. And her midterm grade happens to be 35. Okay, so why don't we look at a simple example of that. So I'm going to cut this thing on. want to give me the laptop. I don't want the laptop. Nope. There we go. Okay. Did you cut the lights off back there? So let's. This is our first example of struct. So I'll just call this str.c. Yeah, that looks like string. stru. But struct is actually this. Oh, I'll call it struct.c. There we go. And so, yeah, certainly sharp include standard io.h. We're going to have a, so let's set up our new type. So we're going to say struct stu. So that's our type. It's open brace, closed brace, and then with a semicolon here marking the end. And then we're going to have these three fields. We're going to have this integer field, sn. So that's basically the student number. We're going to have the student's name. So it's an array of size 50 characters. And finally, we're going to have the midterm grade, int midterm, like that. So here's main. So we get to use this name just like you use any other type name. Like here, I've got the type name int, and I specify I'm going to have a variable or a field. Part of the student is going to be sn. Another field or part of student is going to be of type character, and it's going to consist of 50 characters. Okay, so if I say here then, stu s, then I'm declaring s to be of this type. And so I can say things then like s dot student number. So notice what you do. If I want to get to this field, so s consists of this unit that has in it these three parts or these three fields. And so to get a hold of this first part, I use the dot. Yes?
So you had a group of students. Could you declare like an array
Sure.
of the structures?
You could say here, stu, and so then what we have here is we have this thing here is an array of 100 students.
So if you wanted to access like the student number, would it be like array and then the index?
So yeah,
dot?
you say you wanted to print out something, you'd we'd say array brackets whatever, say 35. So array brackets 35, that's a student. And so then I'd say dot sn. So yeah, this is just as good of a type as the built-in types, and you get to use it just like the built-in type. So right down here, though, I'm just going to say equals 991, 2, 3, 4, 5, 6, 7, and then let's put a value in to the name. So we need to do a copy, string copy. So into s.name, we are copying, I think we had Alice Baker. That. And finally, s.midterm is equal to, say, 35. So let me take out this array. I mean, we've got it there. So to check that this is, I guess we're going to need one other thing. if you're using string copy, there's a, we have to include, to use string copy, I have to include string.h. Remember that copies from constant over here to a destination. Okay. So I guess I need one more sharp include. String.h. So we should be able to do things like, right below here we could say, printf quotes, I'm missing a foot or something. And there we go. Percent %d, so I'm going to print out the student name, and then a space, and then, sorry, student number, then a space, then the name. So what is that? That's a string, so percent %s, then a space, and last the grade on the midterm. So that would be another %d. And so then over here I'm going to have s.sn, s.name, and s.midterm. So, okay, let's run this. So G++, structs you can also do in C, but the notation is a little fancier. It's just a little bit easier. So G++ rather than GCC, only difference here. And this was struct.c. Okay, so /a.out. So we get the 991 number, we get the student's name, and we get that Alice Baker made a 35 on the term. Okay. There's more to learn. So we were talking about new, and that if you said new int, that gave you a new integer. So let's look at this other way of so this is called dynamic allocation. That is, when this is run, when you run new int, each time you run it, and it could be inside of a loop again, each time you run new int, you get a new integer. The op system gives you a new integer. So so you get the new integer, and what does it give you back? It gives you back the address of that integer. So what I want to do down here is I'm going to set up a variable, stu asterisk ps. What is that? It's not politically stupid. It's
are you asking what the abbreviation stands for?
Yeah, what does that asterisk do here?
Oh, it takes you to the value of that variable.
Well,
right.
This is in a definition. So it's saying, what is a stu here? It's not ps. If you dereference ps, you get a stu. So ps is actually a place for an address. Yeah. So over here to the side somewhere, ps is a place for the address of a stu. In fact, let's put one there. Equals new stu. So new does what it always does, whether it's for a built-in type or one of our own type. It asks the operating system, give me a little space. Okay, so the operating system gives us a little space. And new returns what? New returns the address of that space. And where am I putting that? I'm putting that into PS. Now this is a confusing thing. Normally, this is a definition. Normally when you've got asterisk PS and you've got an assignment, you are assigning not to PS, but here's a picture. Here's computer memory. Someplace I've got PS. What's inside of PS? PS is a place for an address. And so PS refers to some other place. In fact, since PS is the address of a student, we're going to have, it's going to refer to something that has three places in it. A student number, a name, and last is midterm. So here's how the picture works. Asterisk PS is this other place. So if you do an assignment, you're assigning something over here, normally. But this is where I'm, okay, so what's special about this line is this is where I'm defining PS. How can you tell it's a definition? I think I asked that question the other day, didn't I?
Because that's an operator.
Because you have a type name in front of it. Why is this a definition up here? Because there's an int in front of it, and that's a type name. So this thing right here is a definition. So normally, when you see asterisk PS equals something, you are putting something over. So this is PS. This thing over here is asterisk PS. Yeah? Okay. So normally when you see asterisk PS equals something, you're putting something over here. The one exception, because well, C and C++ programmers are lazy, are when you're setting up a variable. This value here is not going into asterisk PS, it's going into PS, and that's good because what is PS a place for? PS is a place for an address of a student. What does new return? New creates a student and returns the address. So in this definition, we are actually putting something here. Later on, when I use asterisk PS, though, that's not going to be the case. Then I'm going to be talking about this other place. So what this does then, this sets up PS as a place for an address of a student. This thing over here creates, asks the operating system, give us a student, and new returns an address. So we are indeed putting an address over here. Okay, now, say I want to put, say I want to, next line. I want to, give this new student a student number, a name, and a midterm grade. This part is unfortunate. Yeah, so I want to say like asterisk PS. So PS is the address. Asterisk PS is this place over here. So I'd like to say this, asterisk PS dot SN equals 991 765 321. Okay. Well, whatever. Yeah. Let's see, 765 432. Okay. So, and then I'd like to say this, but there's a problem here with precedence. That we've got a dot and we have an asterisk. The situation is that the dot has higher precedence than the asterisk. That's mostly C and C++ do precedence is the way. What you really want to do is you want to have so PS is not a student. What is it? It's an address of a student. Asterisk PS is the student. And so I want the student number part of a student. But this dot is going to apply not to asterisk PS, which is the student it's going to apply to. It's going to apply to, instead, this address. The address doesn't have a part. The address is just an address, like 35 Wabash Avenue. So the 35 doesn't come in parts. You can't talk about the student number part and the name part. So this won't work. Let's look at the error that we get. So let's go back and we're going to do the G++. Request for the member student number SN in PS. So this is a pretty good, it's complaining about just what I said. We're looking for the student number in PS, which is a pointer. So a pointer is an address. It doesn't have parts. So there's two ways of fixing this. Here's the first way, is that we insist, we tell C++, we put parentheses around this, so we're saying, by God, we want you to give us the student. So PS is an address, but asterisk PS is this other place. We're insisting we're doing the asterisk before the dot by putting the parentheses in. Okay, let's see here. Hey, it doesn't complain anymore. Okay. However, again, the C programmers are lazy, and so they've developed an alternate notation that everybody uses. You get to say this in place of what's above. PS, arrow, SN. So that replaces this. Let's see now. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. It saves 2 characters. Okay, so this arrow stands for putting the asterisk inside of parentheses and then doing the dot. So it's supposed to remind you that this thing over here is what kind of a thing? It's an address. It's an arrow. What's inside of PS refers to, notice the arrow there. So I'm taking a dash and a greater than sign. Arrow, that's an arrow. So this is an alternate notation to this. And so I can tell you what we'll do. We'll use the second one to print things out. So I'm going to say here, printf, quotes, %d, \n, in quotes, PS, arrow, SN. So here are the two different possible ways of writing the same thing, with the arrow or with the, I'm going to pretty much use this because I'm definitely lazy. Okay, so we get all that stuff about Alice, but we also get this other thing. So when you have pointers, so the moral of the tale is that when you have pointers, you need to put the asterisk, so this is the pointer, so it has an address. The asterisk actually gives us the new student structure, and then we can talk about the parts of it. Or you can do it this much shorter way, and that works fine. So for instance, we could then say PS, well, string copy, PS, arrow, name, comma, I don't know, Cam, Newton. There we go. And PS, arrow, midterm. Equal, I don't know, 40. There. Got over the 38. And then we could come down here, we could do this printf and print everything out. Except over here, I'm going to have here PS, I'm going to have PS, arrow, SN, comma, PS, arrow, name, and PS, again, it's a dash and a graded arrow midterm. Okay, so we've got Alice Baker with a 35 and Cam Newton that got over the 38 that was possible. Okay. Any questions on this? Let's go back and look at the code. Yes?
I'm getting caught up on the definition of PS, asterisk PS.
Mhm.
So the way I look at it is, okay, so we have asterisk PS, which is going to be the location of some value of the address of PS.
So,
right?
yeah.
Are we assigning, it seems to me that it's assigning the address of a new stew structure to the location of PS.
Yes.
Is that correct?
Yes. This, and that's what I'm saying. This is
So PS would be the address of an address?
it's not that bad. It's an address of a struct.
PS by itself, without the asterisk.
Yeah, PS is an address.
Yes.
And so to actually, so yeah, we could print it, so if we printed PS out, we could maybe see that address, which is not terribly interesting. Asterisk PS is the place, so PS refers to another place in the computer.
I understand that, but since we're using new, isn't that returning an address of what you're declaring?
Yeah, it's returning the address of enough space to store a student. Yeah.
Oh, okay. Okay, never mind. I understand that.
So what does the op system do when it sees this? It figures out how big this is, and it can do that by looking at this definition up here. So it knows how many bytes to assign from memory.
What's the benefit in using that instead of just using like declaring STU?
Yeah, well that's the next thing.
Okay.
We might have, okay, so the very next thing, we have how many more minutes? Yeah, we've got like 13 more minutes or something like that. Yeah, okay, so let's move on from here. So the next thing, well, where did I just do that? That was supposed to be in 201. And that was called, okay, I need to move that. So that was from my home directory. That's terrible. Move this thing that was called struct.c. I want to move struct.c. So my home directory / struct.c. I want to move that to here. Okay, so it's going off the screen. But yeah, there it is, way over there on the right on the third line up from the bottom, struct.c. So what we're going to make now is we're going to make a linked list. So it's going to have a struct in it, but it's going to be a little different here. So one thing structs are good for is bringing together related data. You know, someone's name and someone's student number, they belong with that particular student. That particular student has that student name and has that number. But it's not the same type of data. In an array, all the data is the same. But a record or a struct is about taking disparate data, like character data for a name and numeric data for a grade, and combining it. Here, we're going to have a whole bunch of data, and we're going to keep track of it by storing the data one at a time. Our data here is just an integer. And each time we get another integer. So down here in main,
You have a semicolon after the curly brace.
hmm?
Up there in the box structure.
That's how the struct syntax works.
Here, semicolon here?
Yeah.
Yeah, so inside of main down here, yeah, you don't normally have semicolons after compound statements. But this is not so much a compound statement. This thing, it's a compound data structure, but it's not a statement. So the semicolon's required.
That's for every structure you make.
Yeah, for every struct. Right. Okay, so now what we're going to do is we're going to have a loop that gets data, and it's going to store that data in a box. Okay, so let's do this. We're going to do this right. So while 1 equal scanf quotes, we're looking for an integer, %d, and we're going to put that into x. So I need to set x up, ampersand x. So right above here, int x. And what are we going to do? We're going to take that. So what are we are getting an integer out of the input, and we're going to put that into a box. So if I have a new integer, I need to have a new box. So down below here, I'm going to set up box asterisk. I'll call it NB for new box, and I'm going to say over here asterisk NB equals new box. So in place of the student, we've got a box. And so when I say new box, I'm going to get enough space to store some data and have an address of the next box. Okay, so let's talk about what's going to come next. So I'm going to say here NB arrow data equals x. So I'm getting a number out of the input, putting it into x, and then I'm copying that. Then we make ourselves a box, and we are putting that new piece of data into the box. And then we're going to put this into our list. So we're going to say here, so this is the part that I'll need to explain. We're going to say here that NB arrow next equals head, and head equals NB. And this will keep on going until we run out of data. And then I want to print out everything that's in the list. So let's write that part. The current box, so we're going to say box asterisk current equals head, and while current is not equal to 0, we're going to do the following two things. We're going to print the data, so printf quotes %d \n. So this, I really want you to understand this. Current arrow data, and then current is going to be equal to current arrow next. And I need to enclose this inside of braces here. And that's it. Let's take a look at what happens. Would you cut the lights back on again? Okay. We're going to start off with head having a 0 in it. 0 is an address that means we're out of addresses. So head has a 0 in it. And let's say we run this scanf and we get a number. And we put it in X. So give me a number.
5.
that's a good number. We put it in X, and that's here. So if we're successful with getting one number, scanf then returns a 1, these two things are equal, we come down below and we make ourselves a new box. So here's a picture. I'm going to have NB points to a box that has two fields in it, a data field and a next field. Remember, those are the two fields up there. What are we doing? I'm taking the value that's in X, which happens to be a 5, and I'm putting it into the data field. I'm taking the value that's in head, so just go along, what's in head? There's a 0 there, and I'm putting it in here. That 0 basically means stop. We'll see how that works in a second. And then the last thing that we do at the bottom of the loop is we say head equals NB. So head no longer has a 0 in it. Instead, head points to this, whatever value is in NB, and what NB has in it the address of this box, and so now head has that. Now we could be, for input, we could be typing in 5 numbers, we could be typing in 1,000 numbers. It's pretty much up to us. Once we've done all of these steps, we're going to go back up and redo the scanf. So scanf is going to try to get another number. If it can't find one, great, we'll stop and move on down here. But let's say scanf gets another number. I don't know. Give me another number. 7. Okay, so there'll be a 7. So scanf will put a 7 in X, and it will return a 1. These two things will be equal. So since that's true, we're going to carry out all these steps. We're going to get ourselves another box. Each time we run this, we are asking the operating system, give me a new box. And so we'll get a completely new box, and NB will point to that new box that right now has got garbage in the data and garbage in the next. Let's take a look at what happens. We are taking what's in X and putting it into the data. So that's a 7. A 7 is going in here. We are taking what's inside of head and putting it into next. What does head have in it right now? Head has in it the address of this first box. So we are putting into this next field, we're putting in it the address of this box that was first. Kind of what we're doing is I'm trying to put this box in front of the box I already had. I'm squeezing it in the front. And the last step is head equals NB. So head is now going to have in it, so NB has in it this box here, so head, instead of pointing to here, so in terms of a picture, this is, the one thing I really hate is not having more space. So head was 0. Head was 0. Then head had in it the address of our first box that had a 5 and a 0 in it. And now, so this is the second picture. And then the next picture of head, head has in it the address of the box that has the 7 in it. The 7 is hooked up to the box with the 5 in it. And the 5 has a 0 here that means stop. The next time we get input, we'll be putting the new box. It'll be like this. Each new box is going to go in front of everything else. So whether we have 1 item or 1,000 items, this will work. Now let's look at the last part. I just want to move this up a little higher. We start this variable off with whatever's in current, with whatever's in head. Well, what's in head is the address of the very first box. And so what are we doing? So if current has in it the address of the very first box, current arrow data is the data in the first box. We're printing it out. And then what does this do? Current arrow next takes us from the first box to the next box. And if current is not 0, we will go back and print up the data in the next box. Okay, let's run this real quick. So G++, remember it's not GCC, it's G++. This is linked list. So the name should be, I need a sharp include up here. Standard io.h. You said there was a semicolon missing too?
Yeah, it's under print F in the current loop.
Yeah, I see that. Okay, let's see if we can't get this to compile. Hey, it's happy, so /a.out. So I'm going to put in 1 and 2 and 3 and 4 and 5. Then I'm going to do a control D, that means into file, right? Hold down the control P, type the D. And so what prints out now, and so the last thing put in was the 5, so that'll be at the head of the list. And the thing that I put in before the 5 was the 4. 5, 4, 3, 2, 1. So the point here is it doesn't make any difference whether we're going to have just 5 data items or 1,000,000 data items. This same program, each time we need more space, each time scanf is successful, we ask the operating system with the new, give me more space. The operating system gives that space and puts it in NB. NB arrow data, we take the number that we got, we stick it in the data thing. We take this new box, so we've got this big, long list that's headed by head. And the second part of each box takes us on to the next box. And so we have this new box. And so what do we put here? Head has in it the address of the current list. We copy head here, that's this line. So this box is now hooked up at the beginning. How do we make sure it's at the beginning? We do this next line, we say head equals NB. NB refers to this box here, so when we say head equals NB, head instead of pointing here now comes down here. And so we've added this new box onto the beginning of the list. So that's kind of neat. You get, with this dynamic allocation, we get storage as we need it. We don't have to say, well, I know I probably won't have more than 100 items, so I'll declare an array of size 100 or 1,000. Here you can just do it. Each time we get more data, we store the data. We create a box. We ask the operating system to create a box. It makes a box for us, and we store the data in the box. Okay. So this thing is called a linked list because each box is linked to the next. And way at the end, we have a 0, which means time to stop. So 0 is the address the special address that means we really don't have another address. It's time to stop. Okay. So this code, so this is linked list. So we have a pair of programs that it's worth studying. Struct.c and linked list.c. Both of these are in this 201 subdirectory. You should look at them. Okay. And thank you for staying through the week over. Because you have nothing else to do, like go to a